This is review for exam 1. Reviewing by taking some examples. So for example, find the first derivative y prime or dy dx for y equals 9x to the 4/3 minus x cubed plus 27. To find y prime, by the power rule, we bring 4/3 down, subtract 1 from the exponent, like so, minus, bring the 3 down, subtract 1 from the exponent. Derivative of 27 is 0. We can reduce by 3, 1 by 3, 3, 12x to the 1/3, 3x squared. Or we can ask you to differentiate y equals x squared over x plus 7. How do we find the derivative for this? This can be done using quotient rule. Quotient rule. Squaring the denominator, we take the numerator derivative times the denominator minus the numerator times the derivative of the denominator. Y prime equals, this is 2x, keep this the same, keep this the same times 1, and keep this the same. We never expand the denominator, keep that in mind. We never expand the denominator, we always keep the denominator the same. So to find y prime, finish it up, we need to multiply this by this, 2x squared plus 14x minus x squared, and this stays the same. The top you get x squared plus 14x over x plus 7 squared. That's what we have. Now, if y equals x to the 6 minus 2x to the 3rd plus 100, find d cubed y dx cubed. What is this? Y prime equals 6x to the 5th minus 6x squared plus 0. Then y double prime, 30x to the 4th minus 12x, and y triple prime, which is 120x to the 3rd minus 12. This is what we are looking for, the second derivative of the function with respect to x. Another example, given revenue function r of x equals 3x squared plus 7, where x is the number of lamps produced. Part A, find the average revenue when x lamps are produced and sold. Find the rate at which the revenue is changing when 4 lamps are produced. Well, very easy to find the first one. The average rate is defined as r of x over x. R of x is 3x squared plus 7 over x. And to find the rate, it's basically the derivative of the average revenue. So the derivative of this means the derivative of 3x squared plus 7 over x. So how do you find the derivative of this? Quotient rule. Squaring the denominator. We take the denominator times the derivative of the numerator minus derivative of the denominator times the numerator. What do we get for this? X times 6x, minus 1, 3x squared plus 7. This becomes 6x squared minus 3x squared minus 7 over x squared, which is 3x squared plus 7 minus 7, over x squared. Now the rate for 4 lamps, all we have to do is substitute x4 into this answer. Find the limit of 3x cubed minus x squared plus 7x plus 11 as x approaches 2. The way we need to do this, we really need to show step by step. If you don't show steps, you may lose points. So the limit of the first one minus the limit of the second one plus the limit of the third one plus the limit of the last one. We can take the 3 out. Cube square. Take the 7 out. And the last one stays the same. Now, this is 2 to the third, 2 square, 2, and 11 stays the same. 8 times 3, 24, minus 4, plus 14, plus 11. And this simplifies to 45. Given this function, say this is -4, they want us to find limit of f of x as x approaches -4. To do that, we look at -4, which is here. If you approach from this side or that side, the y value is heading to 0. But if they ask us to find the limit of f of x as x approaches -3. -3, there are 2 things we need to do. We need to look at what happens when x approaches -3 from the left, and what happens when f of x approaches -3 from the right. -3 from the left, from this side, the y value is heading to 3. From the left side, the y value is heading to 2. Notice they are not the same. So the limit does not exist. We may add another part to this here. Is f continuous at -3? Why or why not? So you have to explain why this works or doesn't work. Well, in order for a function to be continuous, the limit of f of x as x approaches -3 from the right side must equal the limit of f of x as x approaches -3 from the left side, equals f of -3. Now we know from previous parts we have the limit of f of x as x approaches -3 from the right side does not equal the limit of f of x as x approaches -3 from the left side. So we say f is discontinuous at x equals -3. Part D, find f of -3. Find f prime at 1. F of -3, it's this one, so y is 3. F prime at 1, what is that? This is asking us what is the slope, because the derivative at the point means the slope of the tangent line to the function f of x at x equals 1. So f prime at 1, this is 1. What's the slope of this line at that 1? The slope is 0. Find the average rate of change between x equals -4 and x equals -3. The slope of the secant line. That's what average rate of change is given by y2 minus y1 over x2 minus x1. So when x is -4, what is the y value? So if I go back up at -4, the y is 0. And at -3, we found that it was 3. So it's kind of like this. Think about this way. There's a point here and point here. We need to find the slope of this secant line. So you can call this x1, y1, x2, y2. y2, 3, y1, 0, -3, -4. 3 over -3 plus 4. 3 over 1, which is 3. That's the average rate of change. G, part G, to this, for which value or values is f prime of x and defined. Not defined means that it's not differentiable in this case. If you notice earlier, if you look at the graph, at x equals -3, the function is not continuous. And hence, not differentiable. What about trying to find the equation of the tangent line? To the graph of y equals x squared plus 3x minus 1 at 1, 3. How do you do that? We need to find the derivative, which is 2x plus 3. And then the slope of the tangent line we're looking for is this thing we just found at x equals 1 at this point. 2 plus 3, 5. That's the slope. If you want to find the equation, we finish out by writing the formula. Y minus y1 equals n times x minus x1. This is x1, this is y1. Slope is 5, x minus 1. Y minus 3, 5x minus 5. Add 3 to both sides. We can look at more examples. Find the derivative y prime for each. Y prime is negative 6x plus 7. Y prime, keep the 5 out, bring the 4 down, 2x squared minus 7 to the third times the derivative of the inside by the chain rule, which is 4x. So that's 20 times 4, 80x times 2x squared minus 7 to the third power. Next one, y prime, we use the product rule. The derivative of the first one times the second plus the first one times the derivative of the second. So y prime equals the derivative of this, you bring the 2 down, x squared plus 1 times 2x times, this stays the same, plus this stays the same, bring the 3 down, x squared plus x, subtract 1 times the derivative of that, and that's what we have. How about finding the limit of x squared minus 4 over x squared plus 7x plus 10 as x approaches negative 2? If you pass the limit, that will be 0 over 0. So what we can do, we can factor the top x minus 2, x plus 2, and factor the denominator x plus 2, x plus 5. These cancel. So now all we have to do is find the limit of just this fraction as x approaches negative 2. If you pass the limit, you get negative 4 on the top and 3 in the bottom. Also, before we forget, make sure you know the s of t is the position function. V of t is the velocity, which can be found by finding the derivative of that. And a of t is the acceleration, which is the derivative of the velocity or the second derivative of the position. Find the difference quotient. F of x plus h minus f of x all over h for the function f of x equals 2x plus 9. I always try to find f of x plus h on the side by replacing the x with x plus h, and that would give me 2x plus 2h plus 9. Substitute all of this in there. So you get 2x plus 2h plus 9 minus the function itself all over h. So that gives us 2x plus 2h plus 9 minus 2x minus 9 all over h. These cancel, so we get 2h over h. The answer is 2. More examples. Find f prime at 3 if f of x equals 2x squared plus 5x minus 11. To do that, we need to find f prime of x first, which is 4x plus 5. then the derivative at 3 is 4 times 3 plus 5. 12 plus 5, 17. Next one, prove the function f of x equals 5x minus 1 if x less than 2, and 3x plus 3 if x bigger or equal to is continuous. So the limit of the function as x approaches 2 from the left side equals the limit 5x minus 1. 5 times 2 minus 1, 9. Also, we check the limit as x approaches 2 from the right side, because we need to see, as x at x or around x equals 2, is the function continuous or not. Limit as x approaches 2 from the right side of 3x plus 3. 3 times 2 plus 3, 9. Also f of 2. F of 2 we substitute into the second one. Also 9. We say since the limit of f of x as x approaches 2 from the left is the same as the limit of f of x as x approaches 2 from the right equals f of 2, then f is continuous at x equals 2 and hence continuous. Question: if the limit of f of x as x approaches 11 exists, then does do you think f of 11 must exist? The answer is no. So it's false. How can you prove this? We call it a counterexample to convince the other person why it's false. It's called counterexample. So an example on this could be something like this. This is a function f, and let's say that's 11. So the limit as x approaches 11 exists from right and left side. They go the same thing, but f of 1 it doesn't exist. That's what you need to make sure. First you study for the exam, the notes from before for all the sections, then you come back to this and do them again.